Okay, so today we are doing Unit 1, Lesson 4, Scaled Relationships. Our learning goal is let's find relationships between scaled copies. So we're going to keep going on our quest of scaled copies. So we're looking at, in this first activity, we're looking at these polygons, and we are told that they are scaled copies of each other, and then we're asked to name two pair of corresponding angles. So corresponding means they're in the same place but on different figures. So if I look at, let's say, this angle right here, angle DCB or angle C, that corresponds to angle HGF right here, or angle G, and that corresponds on the little one to this one right here. All right. We could also say, all right, we've got this angle down here, angle A. Well, angle A corresponds to angle E down here, or angle I over here. Okay? Then we know D corresponds to H, H corresponds to L, B corresponds to F, and F corresponds to J. All right. So what can you say about the sizes of these angles? Well, C looks like G, looks like K. F and B look the same. This small one down here looks the same. These are obtuse. They look the same. All right. So it looks like the angles are all the same. It looks like. So now we're going to check our prediction by measuring at least one pair of corresponding angles using a protractor, and I realize that you don't have a protractor at home probably, but that's okay. You can watch me do it. So let's look at this little angle down here. Let's try that one. So I'm going to put the dot, I'm going to line that up, and that looks to be about 50 degrees. Well, let's try it on here. Let's see what we got here. Line up on the line, the dot in the center, and it looks like I'm going to start here at 0, and it looks to be about 50 degrees as well. All right, let's try, let me turn the paper around, let's try this angle F here. Okay, put the dot, the line on the line. What do we got? Looks to be a little bit more than 90, maybe 95. Okay, let's come over here and test this one and see if we get the same thing here. Okay, this one looks to be about 95 as well. So our prediction that they look the same is they are the same by using our protractor. All right, so for the next activity, each of these polygons is a scaled copy, and we already checked the corresponding angles. The side lengths of the polygons are hard to tell from the grid because we've got diagonals, don't we? But there are other corresponding distances that are easier to compare. Identify the distances in the other two polygons that correspond to DB and AC. Record them in the table. All right, so let's try some colored pencils here. So DB is from here to here. Well, what corresponds to that? And that's 4 units long. What corresponds? HF. So we're going to write HF right here. And that equals 1, 2, 3, 4, 5, 6 units. And then over here on the smaller one, what corresponds? LJ. And that looks like it's 2 units. Okay, then we have, whoops, what did I just do wrong? Miss Laird just put it in the wrong place. Let's try this again. LJ goes right here with 2. Okay, now we want AC. So let's see, AC goes from here to here, what corresponds to that? Oh, GE corresponds to that. And that is 1, 2, 3, 4, 5, 6, 7, 8, 9 units long. And then what corresponds on our little guy over here? This line right here, and it's 1, 2, 3 units. So that would be KI, and that is 3 units. So now looking at the values, what do you notice? Do you notice anything? Well, how do we get, let me see what goes on there. Okay. How did we get from 4 to 6? 4 to 6. 4 times what is 6? 4 times 1.5. All right, let's test it. What if we took 6 and multiplied it by 1.5? 6 times 1.5. 6 times 1 is 6. Half of 6 is 3. Yes, it is. That's times 1.5. Okay, let's look at this right here. How do we get from 4 to 2? What's our multiplier? Yes, you can divide it by 2, but our multiplier is 1/2. Okay, what's 6 times 1/2? Oh, 6 times 1/2 is 3. All right, so what do we notice? That the distances also are affected by the scale factor. All right, so let's look at this one. It says the larger figure is a scaled copy of the smaller figure, and if we know that AE equals 4, how long is the corresponding distance in the second figure? Well, the corresponding distance would be HL. So we want to know HL equals how many units? Well, we are given this right here. Does this side, let's try colored pencils again. Does this side correspond to this side? Yes. And this goes from 6 to 15. So how do we figure out 6 times what equals 15? Well, we can think in our head, so let's think 15 divided by 6 equals 2.5. So I'm kind of thinking that in my head. So that means to get from here to here, I used a scale factor of 2.5 to go from here to here. All right, we just discovered in the last activity that the scale factor also affects the distances. So if this distance is 4, I'm going to take 4 and multiply it by 2.5, and that's going to give me, what's that going to give me? That's going to give me 10. So the distance for HL is 10 units. All right, then we are told that IK is 5. So IK is right here, and that is 5 units. The corresponding one is BD. Now, when we went from the little to the big, we multiplied by 2.5. Well, now we want to go from the big to the little. So we're doing the inverse, so we can divide it by 2.5. So we can think to ourselves, 5 divided by 2.5, because we're going from the big to the little, that is going to equal 2. So that means our line segment BD equals 2 units. All right, so the same rule about multiplying by the scale factor applies to distances, corresponding distances as well. Okay, so now we've got 2 quadrilaterals, And my says that ZSCH is a scaled copy of XJYN, but Noah disagrees. Do you agree with either of them? Explain your reasoning. All right, so we've talked about the scale factor multiplies all the distances or the side lengths the same, and the angles have to all be the same. So let's look at them and see, are our angles the same? Well, they look pretty close. Okay. Let's try our distances because these are all diagonals. So let's look at this distance here, and the corresponding distance would be right here. So this is 1, 2, 3, 4, 5, 6. So this is 6. 1, 2, 3, 4. So how do I get from 6 to 4? So I'm going to think, well, let's see what they got us doing here. Okay, record the corresponding distances in the table. So we just did that. That's why I got ahead of myself. So this is 6. They also want us to find JN. So that's this line right here. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Then they want us to find ZC, which we found was 4. I got ahead of myself. And then we want SH, which is this line right here. And that is 6 units. Okay. What do you notice? What do you notice there? Anything? Well, let's look at it and see. So this went from 6 to 9, so that is multiplying by 1.5. So to go from here to here is times 1.5. What's 4 times 1.5? 4 times 1 is 4, plus half is, oh, that's times 1.5 as well. Okay, so it looks like the corresponding distances are the same, and we said it looked like the angles are the same, but they want us to go ahead and measure them so that we are for sure about it. So if you take your, guess we don't have a table, let's measure at least 3 pairs of corresponding angles. All right, so let's take this little angle down here, so angle J, and that corresponds to angle S. So let's try angle J. So angle J right here. Let me make my line so I can see it. Sorry about that. It's going to be my orange line. Kind of gets lost on here sometimes. Okay, that looks to be about 40 degrees. Okay, so angle J is 40 degrees. Angle S, color that so I can see it. Angle S, oh, angle S looks to be about 45 degrees. Okay, well, our corresponding angles are not congruent. Let's try another one to see. So let's look up here at angle N. So if I put this here, angle N is an obtuse angle. Let me color it so I can see it again. It's hard with all these black lines. Okay, angle N goes over to here, so that looks to be about 135. Now, what corresponds to angle N? Angle H. Let's see what angle H is. Have I made y'all dizzy moving this around? Okay. So we're going to move this. And we're going to come over so I can read the numbers. Oh, starting at 0 over here, this is only 110 degrees. So are my corresponding angles congruent or equal? No, they are not. So these are not scaled copies of each other. So did the results change my answer in the first question? It sure did. Okay, because we said they looked the same, but they weren't quite the same. All right, so here are two more quadrilaterals. Kieran says that polygon EFGH is a scaled copy of ABCD, but Lynn disagrees. Do you agree with either one of them? So let's check the angles first. 120 corresponds to that one. This one corresponds to that one. This one corresponds to that one. This one corresponds to that one. So the corresponding angles are congruent. So we've checked that box. Now we need to look at the lengths of the sides. Well, going from 2 to 1, that is multiplied by 1/2. If I take 4, the corresponding side is 3. Is 4 times 1/2 3? No. Okay, so are these scaled copies of each other? No, they are not scaled copies of each other because they are not multiplied by the side lengths are not multiplied by the same scale factor. All right, are you ready for more? All side lengths of a quadrilateral MNOP are 2, and all side lengths of quadrilateral QRST are 3. Does MNOP have to be a scaled copy of QRST? Quadrilateral has 4 sides. Looks like a square to me if they're all 2s. Okay, and another quadrilateral where they're all 3s. Okay, would they be scaled copies? Yep. Angles are the same, they're all right angles. But what if instead of a square, I drew a rhombus? All the sides are 3, but the angles are going to be different. So is this a scaled copy of that? No, it's not. All right, in the last activity, we're going to have 2 pictures of a bird, and we're being asked to find evidence that one picture is not a scaled copy of the other. All right, so here's our picture of our bird, and we're not given any measurements, so we need to come up with a way to compare the two to figure out. So what if I drew a line? We're talking distances again. What if I drew a line, let's say from this point to this point to this point, and created a triangle here? Do the same thing on this bird. Okay, so I'm going to draw this here. So I found corresponding points, and now I'm going to draw a polygon, actually a triangle, and then I'm going to see if the 2 triangles are scaled copies of each other. If they are scaled copies of each other, then this is a scaled, the drawings or the pictures are scales of each other, but if they are not, then, okay, so let's look. Well, this angle looks similar, but this angle, does that look like that angle? Let's see what that angle is. So this angle is upside down. Let's try it again, Miss Laird. This angle looks to be about 115 degrees right here. Are you where you can see it? Yep. Okay. Let's test this angle. Oh, this angle, the corresponding angle, is only 80 degrees. So are they scaled copies? Nope, this is about 80 degrees, And we said this was about 115 degrees. So they are not scaled copies. All right, so we've talked a lot about corresponding distances are affected by the scale factor. Corresponding sides have to be multiplied by the same scale factor. And the corresponding angles must be equal or equivalent or congruent to each other to be a scaled copy. All right, I hope you enjoyed today's lesson and you grew your math brain a little bit, and I will see you on Zoom.